Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we started exercise 12.2 and the topic of this exercise was find the derivative or differentiate with the help of chain rule. But what I told you in last lecture, we can do each and every question without the help of chain rule. So first I would suggest all those students who are watching my lectures first time, kindly first go to my playlist. There is a folder name is ADMath. Watch previous lecture of this exercise, then you will have good command on this topic. Today we are going to do remaining questions of this exercise. In last lecture we did question number 1, 2, 3 all parts. So let's start question number 4. Find the gradient of the curve. Question number 4. Y is equals to 2x minus 5 to the power 4 at the point 3, 1. Gradient means find the derivative. So dy by dx. What I told you, how to find the derivative? First write power, subtract 1, always subtract 1 from the power. 4 minus 1 is 3. Multiply by the derivative of the function. What is a function? Function is which is written below the power. The function in this question is 2x minus 5. So the answer is only 2. So 4 to the 8 into 2x minus 5 to the power 3. Now we have to find the gradient which satisfied this point, that is dy by dx at 3, 1. Means we have to put 3 where we see x in the answer, and we have to put y where we see y. We have to put 1 where we see y in the answer, but in this case only x is present, so we have to put 8. 2 multiplied by x is 3 minus 5 to the power 3. 8. 2 3 is a 6. 6 minus 5 is 1 power 3. 8. 1 to the power 3 is 1. 8 1 is 8. This is our final answer. So the gradient of the curve at 3 1 is 8. Hope you understand the question. Kindly wait. I am checking the answer in the book. I always check the answer in the book in order to satisfaction of student as well as teacher. Yes, correct answer is 8 and we got 8. Move to next question. Question number 5. Find the gradient of the curve y is equals to 8 upon x minus 2 to the power 2 at the point where the curve crosses the y-axis. Students, you must know when the curve crosses the y-axis, the value of x is 0. When the curve crosses the y-axis, the value of x is 0. Hence, y is equals to 8 upon x is 0 minus 2 square. 8 upon 0 minus 2 minus 2 minus 2 square is 4. 4 2 is 8. So y is 2. Now put this value of y is 2 in the given equation. That is, replace y by 2 is equals to 8 upon x minus 2 whole square. This 2 cancel by this 8, 2 4s are 8, and remaining is 1, and this x minus 2 is divide over here, it should multiply by 1, so x minus 2 whole square is equals to what? 4. So x minus 2 taking square root on both sides, so square root of 4, x minus 2 is square root of 4 is 2. So x is equals to minus 2 shifted over there, 2 plus 2 is 4. Now take the equation again, y is equals to 8 upon x minus 2 whole square, or y is equals to shift this x minus 2 to becomes the numerator. Now find the derivative. Derivative means find the gradient. dy by dx is equals to 8 into minus 2 is minus 16, x minus 2 minus 1 is minus 3, so minus 16 upon x minus 2 minus 3 becomes 3. Now satisfy the value of x by the given by the gradient. So dy by dx, we have find the value of x4, so x at x is equals to 4, so minus 16 upon x minus 2, 4 minus 2 power 3, dy by dx at x is equals to 4, minus 16 upon 4 minus 2 is 2, 2 cube is 8, 8 to the minus 2. But students, we have to find one more value from here, because when we take square root on both sides, we have to put plus and minus sign. So one value is 2, other value should be minus 2. Okay, so x minus 2 shift over there, it is plus 2, the answer is 0. Now find the gradient for this value as well. So dy by dx at x is equals to 0 is minus 16 upon 0 minus 2 power 3, minus 16, 0 minus 2 is minus 2, minus 2 cube is minus 8, so 8 to the 16. Now the question is, which answer is acceptable, 2 or minus 2 or both? The question will tell us that which question is acceptable. Find the gradient of the curve y is equals to 8 upon x minus 2. Student, crosses the y-axis. The gradient of the curve crosses the y-axis. Crosses the y-axis, we have find the value is 2. So at x is equals to 0, the value of y 2. Therefore, the only answer which is acceptable is 2. I hope you understand. Move to next question. Question number 6. Question number 6 is find the gradient of the curve y is equals to x plus 4 upon x minus 5 where the curve crosses the x-axis. Crosses the x-axis means the value of y is 0. So we have to put 0 over here. X plus 4 upon x minus 5. 0 is equals to taking the LCM x minus 5. X minus 5 multiplied by x plus 4 x minus 5 by cancel by x minus 5. This x minus 5 multiplied by 0, it is 0. X into x, x square, x into 5, 5x plus 4. So x square minus 5x plus 4 is equals to 0 is the quadratic equation. We have to solve this quadratic equation by using middle term break method. So 4 ones are 4, 4 and 1 5, x square minus 4x minus x plus 4 is equals to 0. X is common, x minus 4 minus 1 is common, x minus 4 is equals to 0. X minus 4, x minus 1 is equals to 0. X is equals to 4 and x is equals to 1. So we have to find the gradient for these two values. Now take the equation again. Y is equals to x plus 4 upon x minus 5. So y is equals to x plus 4. Move this x minus 5 to becomes the numerator. It will be x minus 5 to the power minus 1. Now find the derivative. dy by dx is equals to derivative of x is 1 minus 1 over here minus 4 x minus 5 minus 1 is minus 2. So dy by dx is equals to 1 minus 4 upon x minus 5 to the power 2. This is the final derivative. Now we have to find the gradient one by one. First we have to put x is equals to 4. So dy by dx at x is equals to 4 is 1 minus 4 upon x is 4, 4 minus 5 to the power 2. 1 minus 4 upon 4 minus 5 is 1 and 1 square is 1, that is 1. So 1 minus 4 is minus 3. The first value is minus 3. Now we have to find the second value by putting x is equals to 1. So for x is equals to 1, x is equals to 1, dy by dx 1 minus 4 upon x is 1, 1 minus 5 square 1 minus 4, 1 minus 5 is 4, 4 square is 16, 1 minus 4, 4 the 16, 1 upon 4, 1 minus 1 upon 4 is 0.25, 1 minus 0.25 is 0.75. So the gradient, the final answer is gradient is equals to, the first answer is 0.75 and the second answer is minus 3. This is our final answer. Hope you understand. Move to next question. Question number 7. Question number 7 is, find the coordinates of the point on the curve y is equals to x square minus 6x plus 13 where the gradient is 0. Very easy question, very easy. First write the equation y is equals to x square minus 6x plus 13 square root. Square root means 1 upon 2. Find the gradient. Dy by dx is equals to right power first. Subtract 1 from the power, it will be minus 1 upon 2 because 1 upon 2 minus 1 is minus 1 upon 2. Derivative of x square is 2x. 6x derivative is 6. This is the derivative of the function. Dy by dx is the gradient, the value of gradient 0 in the question. What they wrote? Where the gradient is 0. So replace dy by dx by 0. 1 upon 2 into shifted this minus 1 upon 2 to denominator. It is the square root. Take 2 is common. X minus 3. 2 common from 2x minus 3. Why we take common? Because we can simplify this. Now this x square minus 6x plus 13 root is divide over here. It should be multiplied by 0 on other side. So the answer is 0. X minus 3. Shift minus 3 on other side, it will be 3. So the value of x is 3. Put this value of x is equals to 3 in the question. You will find the value of y. So y is equals to x square means 3 square minus 6x, 6 into 3 plus 13 square root. 3 square is 9, 6 3 is 18 plus 13. Y is equals to 9 minus 18 is minus 9 plus 13. Minus 9 plus 13 is 4 root and 4 root is 2. Hence, coordinates are x3, y2. This is our final answer. So hope you enjoy question number 7. Move to question number 8. Question number 8 is, the curve y is equals to a upon bx plus 1 root passes through the point 1 comma 4 and has gradient minus 3 upon 2 at this point. Find the value of a and the value of b. First we have to satisfy this equation by 1 comma 4. So y is 4 is equals to a upon b into x is 1 plus 1 root. So 4 is equals to a upon b into 1 is b plus 1. Shift this b plus 1 root on other side. It is b plus 1 root is equals to a upon 4. In order to eliminate square root, taking square on both sides, so it will be b plus 1 and square of a is a square and square of 4 is 16. This 16 should multiply by other side. 16 into b plus 1 is equals to a square. So a square is equals to 16 into b is 16b. 16 1 the 16. This is equation number 1. Now take equation again. Y is equals to a upon bx plus 1 root. Root means power 1 upon 2. Now y is equals to a into bx plus 1. Shift this to numerator. It will be minus 1 upon 2. Find the derivative. The gradient. Derivative means gradient. A into minus 1 upon 2 bx plus 1. Minus 1 upon 2 minus 1 is minus 3 upon 2 into derivative of the function. That is the derivative of bx plus 1. Derivative of x is 1. So b into 1 is b and derivative of 1 is 0. Now see what is the gradient given in the question and has gradient minus 3 upon 2. So replace this dy by dx by minus 3 upon 2 is equals to a into minus 1 upon 2. Shift this to denominator. It will be 1 upon bx, bx plus 1 to the power 3 upon 2 into b. Now see carefully. This minus cancel by this minus. This 2 cancel by this 2. Okay. Now what is remaining? 3 is equals to a into 1 into b is ab upon bx plus 1 to the power 3 upon 2. Okay. The value of coordinate is given 1 4. So satisfy this by 1 comma 4. So 3 is equals to a b upon b into x. X is 1 plus 1 to power 3 upon 2. So it is 3 is equals to a b upon b 1 is a b, b plus 1 to the power 3 upon 2. Now this b plus 1 3 upon 2 is shifted over there. It will be b plus 1 to the power 3 upon 2 is equals to ab. AB. AB and this 3 is divided over here. So it is 3. Now what is our equation? Equation number 1 was if we take this equation b plus 1 root, if we don't do this, like see carefully what I am doing. I am not doing more. I am assigning the name of this equation is equation number 1. So equation number 1 is root b plus 1 is equals to a upon 4. Root b plus 1 is equals to a upon 4. This is equation number 1. Now see carefully. B plus 1. This is b plus 1 to the power 3 upon 2. So if I write this equation is b plus 1 to the power 1 upon 2 into b plus 1 to the power 1 is equals to ab upon 3. Okay. Now see carefully. Equation number 1 is also b plus 1 to the power half is equals to a upon 4. Replace this b plus 1 to the power half to a upon 4. You can replace dot, and this is b plus 1 is equals to ab upon 3. We can cancel this a by a, so it equation is reduced in terms of b. So b plus 1, this 3 shifted over there, 3 into b plus 1 is equals to b. 3 into b is 3b, 3 1 the 3 is equals to b. So 3b minus b is equals to minus 3. 3b minus b is minus 2b is equals to plus 2b minus 3. So b is equals to minus 3 upon 2. Kindly wait, I want to check the answer. No, the value of b is 3. So I will check all steps again. I think there is some mistake. I will check each and every step. No issue. The curve y is equals to bx root plus 1 upon a upon bx plus 1 root passes through the point 1 4. So y is 4, a is 1. Okay. So sorry, x is 1 and y is 4. Equation is y 4 is equals to a upon b into 1 plus 1. So 4 is equals to a upon b plus 1 root. So b plus 1 root is equals to a upon 4. No mistake over here. Equation number 1 is 100% correct. Now let's check equation number 2. Y is equals to a upon bx plus 1. So bx plus 1 half, power half, because root means power half. Then a into bx plus 1 to power minus 1 upon 2. Then dy by dx is given in the question as gradient minus 3 upon 2. Okay. So I replace correctly. So a, write a first, power minus 1 upon 2, then bx plus 1 to the power minus 3 upon 2, because minus 1 upon 2 minus 1 is minus 3 upon 2, and bx plus 1 derivative is b. No mistake. Dy by dx is given minus 3 upon 2, minus cancel by minus minus, and 2 cancel by 2 on both sides, cross cancelling. So 3 is equals to a into 1 into b is a b upon bx plus 1 to the power 3 upon 2. No mistake. Now 3 is equals to ab upon b, and x is 1. So b 1 is a b plus 1 to the power 3 upon 2. No mistake. Now b plus 1 to the power 3 upon 2 is multiply over there, and 3 will be the denominator. So ab upon 3. No mistake. B plus 1 to the power half, b plus 1. No mistake. So b plus 1 to the power half is equation number 1. So replace this b plus 1 to the power half by a upon 4. No mistake. B plus 1 and ab upon 3. A cancel by a. I found the mistake. Look at this. I forgot to write this 4. 4 into b is 4b. This is the mistake. All steps are 100% correct except this second last step. So 3 is equals to 4b minus 3b. 4b minus 3b is b. So the answer is of b is 3. Now taking any equation to find the value of a. So I am taking equation number 1. Equation number 1 is b plus 1 root is equals to a upon 4. Here b we have find 3. 3 plus 1 is equals to a upon 4. 3 plus 1 is 4. A upon 4. Root 4 is 2. A upon 4. And 4 2 is 8. Hence the value of a is 8 and the value of b is 3. Now I will check the answer. 100% correct. So no mistake at all. Instead of the mistake, second last mistake, I forgot to multiply by 4. So sometime it happens, not for a student but teacher as well. But if we do any mistake and our answer does not match with the answer in the book, so we must check all steps again, just like I did in this question. So I hope you completely understand. Sorry for this mistake, but teacher also do mistakes. What is left in this exercise? Nothing. Nothing is left. Today we have finished the whole exercise from question number 1 to question number 8. 1 2 3 we have already done in previous lecture, but today we have done from question number 4 to question number 8. What next? The product rule. Very, 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 very easy. Very easy. So only one formula will be used in this exercise. How many questions? Just 6 questions. I will try to finish the whole exercise in a single lecture. I will try. Otherwise, in 2 lectures, definitely this exercise will be finished. Similarly, exercise 12.4, only one formula will be used. So this chapter will be end in next 4 to 5 lectures. 12.5, no, not 4 to 5 lecture, 12.6 and 12.7, very easy exercise. 12.8 double derivative, 12.9, no issue, very easy. Practical of derivatives are also very easy. 12.10, how many exercises are left? Yes, so in 12 to 13 lectures I will be finish this chapter, very important chapter according to examination point of view. So this is our today's class. Kindly do practice more and more and more, and if you feel any problem in today's class and previous lecture, kindly write in comment box. I will help you. And I request to all of you, kindly do subscribe my channel, and whenever you subscribe, press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Good luck for next lecture.